YOLO2 projects. In this video, we are going to explain about the project, which is abnormal human activity detection using YOLO v5. So first, we will discuss what is the project about. Abnormal human activity encompasses actions or behaviors that significantly deviate from expected or typical patterns within a given context, including but not limited to criminal activities such as theft, vandalism, or assault, as well as actions indicative of emergencies such as sudden collapses or erratic movements. This can also include behaviors like loitering in restricted areas or engaging in suspicious or destructive activities. The project focus is to develop a system using YOLO v5, which is You Only Look Once version 5, for the detection of abnormal human activities in the video surveillance footage. The focus lies on identifying actions that could potentially pose security threats indicating criminal behavior or signify emergencies requiring immediate attention. Traditional methods for abnormal activity detection often rely on handcrafted features and predefined rules, making them less adaptable to diverse scenarios. They may struggle with complex scenes or unexpected behaviors, leading to high false alarm rates or missed detections. The proposed system utilizes YOLO v5, which is a state of the art object detection algorithm known for its accuracy and speed. By training the model on annotated datasets containing examples of normal and abnormal activities, the system can learn to distinguish between them effectively. Additionally, incorporating techniques such as temporal modeling or attention mechanisms can enhance the model's ability to capture contextual information and reduce false positives. Deep learning plays a crucial role in this field due to its ability to automatically learn intricate patterns and features from large amount of data. Deep learning models such as YOLO v5 can analyze video streams in real time, enabling rapid and accurate detection of abnormal activities without the need for extensive manual tuning or feature engineering. This empowers surveillance systems to proactively identify potential threats and respond promptly, enhancing security measures and public safety. So, the objective of the project is to develop a system that is capable of detecting abnormal human activities in surveillance footage, aiming to enhance security measures and public safety by identifying potential threats and emergencies in real time. The project's focus is on utilizing YOLO v5 for its state of the art object detection capabilities. While YOLO v6, YOLO v7, and YOLO v8 exist, the project specifically employs YOLO v5 due to its proven accuracy, efficiency in real world applications. The project evaluates the performance of the implemented algorithms using standard evaluation metrics such as mean average precision, and recall. These metrics provide insights into the system's accuracy, ability to minimize false alarms, and effectiveness in detecting abnormal activities. The project's outcomes will benefit various stakeholders, including security agencies, law enforcement authorities, public safety organizations, and surveillance system developers. By providing an advanced tool for detecting abnormal activities in real time, the project contributes to enhancing security measures, preventing crimes, and ensuring prompt responses to emergencies, ultimately benefiting society as a whole. To implement this project, we need software and hardware requirements. So coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. Coming to hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. To implement this project, we have designed various steps in the flow of work. So coming to the first step, which is importing the packages. In this step, necessary Python packages and libraries are imported into the project environment. We have imported TensorFlow for deep learning, Flask for web development, and SQLite for database management. So the next step is importing the dataset. Here, the dataset containing surveillance footage or the images of human activities is imported into the project. This dataset serves as a basis for training and evaluating the abnormal activity detection model. Coming to the next step, which is splitting the data into train and test. The imported dataset is divided into two subsets. One is training set and the other one is testing set. The training set is used to train the model, while the testing set is used to evaluate the model's performance on the unseen data. The next step is building the model. In this step, the architecture of the deep learning model for abnormal activity detection is defined. This involves specifying layers, connections, and parameters of the neural network that will learn to detect abnormal activities in the surveillance footage. Coming to the next step, which is training the model. The model is trained using the training data. During training, the model learns to recognize patterns and features in the surveillance footage that correspond to abnormal human activities. This process involves adjusting model parameters iteratively to minimize the difference between predicted and actual labels. Coming to the next step, which is Flask framework with SQLite for sign up and sign in. Flask, a Python web framework, is used to create a web application for user interaction. SQLite is a lightweight relational database management system is integrated with the Flask to manage user authentication and authorization through sign up and sign in functionalities. Coming to the next step, which is user gives input for images and videos. Here, user interact with the web application by providing input in the form of images or the video footage containing potential abnormal activities. This input serves as a basis for model to make predictions. The given input is pre-processed. The input provided by the user undergoes pre-processing steps to prepare it for the input into trained model. This include resizing images, converting video frames into a suitable format, and applying normalization techniques to ensure consistency with the training data. Coming to the next step, which is trained model used for prediction. The pre-processed input is passed through the training model, which generates predictions regarding the presence of abnormal activities in the surveillance footage. These predictions are based on the patterns and features learned by the model during training phase. The last step is final outcome is displayed. The predictions generated by the model are displayed to the user through the web application interface. This allows users to visualize and interpret the results of the abnormal activity detection process, enabling them to take appropriate actions based on detected outcomes. So the algorithms which are used for detecting abnormal activities in the humans are yolov5. First, knowing what is yolov5, we will know what is YOLO. YOLO is short for You Only Look Once. It is a state of the art deep learning model for real time object detection. Unlike traditional object detection methods that require multiple passes over an image, YOLO processes the entire image simultaneously in a single forward pass through a convolutional neural network, which is CNN. This enables YOLO to achieve impressive speed and efficiency while maintaining high accuracy. YOLO divides the input image into a grid and predicts bounding boxes and class probabilities for objects within each grid cell. It is known for its simplicity, speed, and effectiveness, making it widely used in various applications such as autonomous driving, surveillance, and robotics. YOLO is utilized in this project due to its real-time object detection capabilities, allowing for swift analysis of surveillance footage. Its efficiency in processing entire images in a single pass enables timely detection of abnormal human activities with high accuracy. Additionally, YOLO's versatility and ease of implementation makes it a practical choice for integrating into project surveillance system. Coming to YOLO V5, You Only Look Once version 5 is a cutting edge deep learning model specializing in real time object detection. It excels at both speed and accuracy, making it ideal for tasks like self driving cars and video surveillance. YOLO V5 prioritizes user friendliness and offers diverse pre trained models for various needs, while also allowing for customization for unique objects. Overall, it's a powerful and versatile tool for object detection in numerous real world applications. Coming to the next algorithm, which is YOLO V6, it is also known as MT YOLO V6. It is the next generation of object detection model building upon the success of YOLO V5. It is designed with the industrial applications in mind. It offers an exceptional balance between speed and accuracy. It features innovative architecture, improvements like efficient rep backbone and rep pan neck, leading to better performance than its preceders. YOLO V6 provides various models catering to diverse needs, making it a valuable tool for real-time object detection in industrial settings. Coming to YOLO V7 standing for You Only Look Once version 7 reigns supreme as the fastest and most accurate real-time object detection model yet. It surpasses all previous iterations of the YOLO, achieving both top speed, which is ranging from 5 to 160 FPS, and top accuracy, which is 56.8 AP on GPU V100 within this category. Notably, it even outperforms complex models like Cascade Mask RCNN in both speed and accuracy. This groundbreaking model is open source and readily available for various applications. The last algorithm is YOLO V8. It is a state of the art deep learning model by Ultralytics. It excels in computer vision tasks, particularly real time object detection, unlike prior YOLO models. It uses an anchor free approach for faster and potentially more accurate object localization. YOLO V8 goes beyond detection, offering functionalities for image classification and instance segmentation as well. We have used mean average precision, precision and recall, which are the performance metrics to evaluate all the models built in the project. So here we have performance comparison graphs for all the metrics evaluating all the YOLO models. So this is precision score comparison graph. This is the horizontal bar graph where x-axis represents precision score of each algorithm and y-axis represents all the algorithm names. Precision is a metric that measures the accuracy of positive predictions made by a model. It is calculated as the ratio of true positive predictions to the sum of true positives and false positives. This is recall comparison graph, similar to precision. In this graph also, x-axis represents recall score of each algorithm and y-axis represents all the algorithm names. Recall is also known as sensitivity or true positive rate. It measures the model's ability to capture all relevant instances of a class. It is calculated as a ratio of true positive predictions to the sum of true positives and false negatives. This is mean average precision comparison graph. It is a mean average precision. It is a metric commonly used in object detection tasks. It calculates the average precision for each class and then takes the mean across all classes. Average precision in turn is the area under the precision recall curve. So the algorithm which performs well among all these metrics will be used for final prediction. To execute the project, first we have to open the code folder which contains source code files. This is the code folder of the project, and this is the dataset folder which we use for training the algorithms. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in HTML templates. This is the model folder, which contains the algorithm information and that will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. This is the signup.db file. This file is a database file used to store the user information. Now to execute, we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. By this, current directory will change to the code folder's path. So here we can see that current directory is changed to the code folder's path. And now we need to compile the app.py file. For that, type the command python space app.py and then click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port, unless configured differently. So this is the local host and this is the port. Now we need to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. As I prefer Google Chrome, so I'll paste it in that. So I'm pasting the link. Now click on enter. This is the web page of the project, which is displayed in the browser, and this web page is built using Flask framework. So to execute, first we need to sign up if we are the new users. So click on sign up and enter all the registration details and then click on sign in. As I have already registered and I have an account in it, I'll directly sign in. Here we need to provide username and the password. So I'm giving my username and the password. Now click on submit. We have logged in successfully and we are redirected to web prediction page. So here we can see a choose file button. We need to click on that for uploading the CCTV footage for the detection of abnormal activity in the human. Here in the project, we are going to do the detection of abnormal activity in both images as well as videos. So click on choose file button for uploading the files. These are some of the test cases using which we are going to detect the abnormal activity in the human. So I'm going to upload the second image. Now click on open. Here we can see that image has been loaded. Now click on upload. So here in the image, application has detected the abnormal activity, that is criminal activity. So it has drawn a bounding box around it and it has labeled it as criminal and it has given a probability score for that. Now we will try uploading the other images and the videos. So click on try again. Click on choose file. This time we'll be uploading this image. Now click on open. Image has been loaded and now upload it. So here application has detected the abnormal activity of the person and it has drawn bounding box around him and it has labeled it as destroying things with the probability score. Now we will try uploading some more images. So click on try again. Click on choose file. This time we'll be uploading this image. Now click on open and here we can see that image has been loaded. Now click on upload. So here we can see that there are multiple things detected. One is the suspicious activity, which is the abnormal activity detected, which is destroying the things. And a bounding box, which is green color bounding box, is drawn around him with the probability score. And we can see that two persons are detected with the probability score and with the blue color bounding box drawn around him and with the label as person. Generally, probability score of detection indicates the confidence level of a model's prediction. So here we can understand how accurate the model is. Now we will try uploading a video. Click on try again. Click on choose file. So I'm going to upload the first video. Now click on open. Now click on upload. So here in the video, we can see that abnormal activity has been detected, that is criminal, and a bounding box was drawn around the person with the probability score. So as it is a video, we can see the detection only when the person is doing abnormal activity. Now we will try uploading the other images. So click on try again. Click on choose file. This time we'll be uploading this image and now click on open. Click on upload. So here we can see that only car has been detected and abnormal activity is not detected because there is no abnormal activity which is performed by the person. Now we will try uploading the other image. So click on try again. Click on choose file. This time I'll be uploading this image. Now click on open. Here we can see that image has been uploaded. Now click on upload. Here in the image, we can observe that one and two criminal activities has been detected, which is dashing the fence and the other one is criminal activity. Here, car is dashing the fence. Here we can observe that a green color bounding box is drawn around the box, around the fence, and the probability score is given for the activity. Now we will try uploading the other images. So click on try again. Click on choose file. This time we'll be uploading this image and now click on open. Click on upload. Here in the image, a person is destroying things. So destroying things has been detected and a green color bounding box is drawn around him with the probability score. With the probability score, we can understand that how accurate the model is performing. So now we will upload the last image. Click on try again. Click on choose file. Now we will upload this image. Click on open and now click on upload. So here in the image, we can observe that a person is breaking the door. So abnormal activity, which is breaking the door, has been detected with the orange color bounding box drawn around him and with the probability score. Now click on log out. In this way, just by uploading CCTV footage to the system, application will detect the normal activity and the abnormal activity of the human. So the conclusion of the project is the project has been successfully developed, achieving its primary goal of detecting abnormal human activities in surveillance footage. Through rigorous experimentation and optimization, the system has demonstrated its effectiveness in accurately identifying and flagging suspicious behaviors. Among the algorithms evaluated, yolov5 emerged as a top performer, striking an excellent balance between speed and accuracy. Its real-time object detection capabilities proved instrumental in swiftly analyzing video streams and detecting potential security threats or the emergencies. The front end of the project, powered by the Flash framework and integrated with SQLite for user authentication, provides a user-friendly interface. Users can easily interact with the system, accessing features such as uploading surveillance footage, monitoring real-time detections, and managing user accounts. Looking ahead, the project holds significant potential for further advancements and extensions. Future iterations could incorporate features such as real time alerts, anomaly clustering, and predictive analytics, enabling proactive intervention in potential security breaches or emergencies.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.